Welcome back to Low Stress Math with Mrs. Bono. We are in Unit 7, Transformations. And this is the last unit for this year. So yay us. Lesson 1, Congruent Figures. You've heard this term before, so let's just jump into it. Figures are congruent if they have the same size and same shape. Now, same size, you're used to using an equal sign. But same shape we haven't talked about. And that's a tilde, that little kind of squiggle that you would put over an N like an enye. But that means the same shape, and an equal sign means the same size. So when you're talking about congruent, you put the same size, the same shape, the tilde, over the equal sign, same size. And that's the symbol for congruence. And the two figures below are congruent. They're both triangles of equal size and equal shape. Now, the thing is, in a congruent shape, your angles are all going to be congruent to each other. So if this is a 30-degree angle, then that's a 30-degree angle. And if that's a 60-degree angle, then the corresponding angle in the other triangle is going to be a 60-degree angle. And this last one, I don't know what angle that would be, but yeah, 30, it would be 90. But they're both the same size and shape. Now, the angles are what determine the shape. So corresponding means the same place in two different shapes. So if this is A, it corresponds to A prime in the other triangle. And if this one's B, it corresponds to B prime in the second triangle. The same for C and C prime. That little slashy mark is called a prime. It looks like a single quote mark. But now, if you have AB, then that is going to be the same exact length as A prime B prime. And AC is going to be the exact same length as A prime C prime. And, of course, BC is going to be the same as B prime C prime. All right, congruent figures do not have to be facing the same way. Look at the figures below. They are congruent, but they're facing in different directions. I know for a fact they're congruent because I did a cut and paste of the first rectangle and 90 degrees turned it to make the second rectangle. But the same thing is true. The corresponding sides are the same length, and the corresponding angles are the same angles. Right. Which pieces of this puzzle do you think are congruent? That's kind of interesting. Huh? Well, what could we use to help us determine if this was congruent? Well, you guys have rulers on your desk. Let's try taking out those rulers and measuring the size and see if we can figure out which ones are congruent. And we're going to use the millimeter side of the ruler. And I'm going to start with the side for B. And the base of B here is my ruler upside down. You can't read it, can you? It's silly Bono foolishness. All right. Make sure that you're lining up the end of the millimeter with the side. That's why I like these rulers that you can see through. And then look, it is just 2 lines short of being 5 millimeters. So that would make it 4 8/10 of a centimeter, 4 8/10. Now on the other side, look, the bottom, the corresponding side is the exact same 4 8/10. So far so good. Now let's measure this side here. From there to there is 4 1/2. No, 4.6. Yeah, 4.6. So how about this one? Is that 4 6/10? Let's see. Oh, yes, indeed it is. Oh, that's good. How about this one? How big is this one? That's the one I just measured. What am I doing? Foolishness. That one is 4 centimeters, and this one is 3 1/2 centimeters. Truly, none of these things are congruent. How do I know they're not congruent? Because none of the corresponding sides are the same length. So let's write that down. None of these puzzle pieces are congruent. And I'm going to write out the word congruent, and I'd like you to write that out too, but I'm also going to use the symbol for congruent because I want you to get used to that symbol. And remember, it's the little sort of sideways S on top for the same shape, and then the equal sign underneath it for the same size. So none of these are congruent. How do I know? Because none of the corresponding sides were equal. And now I'm looking back at what I wrote. I seem to have invented my own word. That none and of are sort of kind of squishy together. I think I'm gonna grab some white out and fix that because that doesn't look too good, does it? So none of the corresponding sides are equal. I don't even have to worry about the angles right now because if none of the sides are equal, then the angles don't matter. We're gonna figure out that later. All right, so let's take a look at the next page. Look at this. There are no angles in circles. Oh my goodness, that's terrible. Circle the two figures that are congruent. Well, let's take a look. This is obviously smaller than the other two. This one's obviously larger than the other two. I don't even think number 4 is a circle. I think it's an oval. It's kind of squishy looking. But let's look at these other two circles. I'm going to measure the diameter of these circles. How do you measure the diameter of the circle? Well, you kind of you hold it sort of steady on one side and go back and forth until you get the largest line through the middle. And for this one, it is 1 centimeter and 1 millimeter short of 2 centimeters. So that makes it 1.9 centimeters. So let's see if this number 3, which looks like a likely candidate, haha, it too is 1.9 centimeters in diameter. That makes these two congruent because they have the same diameter. So I'm going to circle those two figures. Circle the figure that's not congruent. Well, I'm going to need my ruler again, so I'm going to measure some sides here. So this side, 2 5/10, 2 5/10. This one's sideways, but that doesn't matter because the side here is 2 5/10. And what's this side down here? Ooh, that's 2 3/10. And this one is 3 2/10. That's definitely not congruent to the others. Let's look at this last one. 2 5/10. Okay. Well, look at us. This is the one that doesn't match. Haha. Match the figures that are congruent. Well, this is up to you. I'm going to let you try it. That means pause the video. Honestly, you have to turn it off and do it for yourself. The only way to learn math is to do math. All right, welcome back. I hope that you matched up your congruent figures, and I hope you used a ruler to check them. So, shape A is this square, and it is congruent to number 2. And if you drew a line, that's fine too. This rectangle, shape B, is congruent to this rectangle, 5 down here. So you can either write the number 5 next to it or use a little line. All right, this slightly smaller rectangle matches up to number 1. This very large rectangle matches to number 3. And that means that E, the last one, matches up to number 4, like that. So not too bad, right? Next page. Identify the figures that seem similar. Do you know what similar means? It means they look a lot alike. There are some things that you would think were congruent, but in fact they are not. They're just similar. So if you look at a pair of twins, you would think they were congruent. They look the same, right? Identical twins. They're identical. But you know you've had friends who are identical twins who are not alike at all. They're just very, very similar. They have a lot of things in common. So looking at these shapes, some of them are very, very similar. Let's look at this one. It has a right angle like this one, and it has these two sides congruent to each other, and so does this one. So these two shapes look like they are similar to each other because they're actually, do you remember what you call triangles that have a right angle? Of course you do. Those are right triangles. But how about if they have sides that are equal to each other? Ha, do you remember that? Yeah, that's isosceles. So this triangle and this triangle are both isosceles right triangles. Huh. Now, I have to grab my protractor and measure the angles, but I'm not really going to do that this time because I know for A and D, this angle is congruent to this angle, and this angle is congruent to this angle. So when all three sides are congruent, that means that the triangles are similar. Now, I said congruent and similar in the same sentence, didn't I? Congruent means exactly the same size and shape. Now, those angles are congruent. They're the same size and shape, but the sides aren't equal. That's why these are similar triangles, but not congruent triangles. The angles are congruent. The sides are similar. So that's what we're going to call these. Figure A and D are similar. And similar means they have the same angles, congruent angles, but the sides are in proportion, and we're going to get back to that. So they have congruent angles and sides in proportion. We are going to spend so much time talking about proportional sides. You're going to love it. All right, down here, let's look at these. Oh, look at this. These are both hexagons. And they're both, oh my gosh, the word escaped me. I'll get it back, don't worry. They have all the sides that are equal to each other. Kind of like isosceles, right? They're like equilateral. That's what it means when all the sides are the same. Equal, obviously the same. Lateral is what they call sides. So equilateral means all the sides are equal. These two hexagons are equilateral. Look, this little guy down here. 1, 2, 3, 4, 5. He's equilateral too. So B, C, and E, those are all similar. Now they're obviously different sizes, but their sides are equal within. So they're equilateral hexagons, and that makes them similar to each other. And so it's going to be the same thing. It's going to be B and C and E are similar. Oh, that's my bell.
At this time, the graders may move to their 4th period class.
So B, C, and E are similar, and that means that the angles are congruent and sides are in proportion. All right, complete the sentence. Okay, which sides are corresponding in these similar rectangles? Corresponding means that they're in the same place but in two different shapes. So if I'm looking at C to D, it's corresponding to G to H. Now you figure out which one is corresponding to AB. Try it, you can do this.
Eighth graders, you may now move to your 4th period class.
All right. Now there's one thing I just wanted to mention before we finish up here. These are all supposed to have a line segment symbol above them because line segments correspond. Now down here, these line segments correspond also. A to B corresponds to H to F. And B to D corresponds to F to E. And CD corresponds to HF. Wait. Oh, this should be GE. Sorry about that. And this one is HF. And the last one that corresponds, AC, corresponds to GH. All right. I will talk to you soon. Have a great day.